All right. So in the previous video, we introduced the concept of impulsive forces and how that leads to simplification of the problem that involve these rapid events. A particular example or use case of that concept is when there is impact or collision between bodies. Usually we assume rigidity, but it doesn't have to be that way. Yeah, rigid is good. So that is the topic of impact. Impact is a very complex phenomena, but with a lot of with some reasonable assumptions, we can simplify the problems a lot and use the tools that we already have to study impact. Before fully studying them, we need a bunch of definitions. So assume two bodies, randomly shaped, are contacting each other or colliding at one point. So a few terminology. This point is aptly we call it point of contact. Point of contact. And for simplicity, let's assume we have only a single point of contact between two bodies. Next is plane of contact. So I've already mentioned these forces are normal forces, as the name suggests, are always perpendicular to the contact surface. So in this case, to better define it, we define I think I need more space. Let me create more space here. Like this. Oh, I missed one line. All right. The plane that is tangent or the common tangent at the point of contact is called plane of contact. And that is a plane that normal forces are perpendicular to. And assume each body has some centers of mass. So this is center of mass, center of masses. The line that connects the center of masses, let's call it line of impact. Line of impact. Yeah, that's good. So with these definitions, we can rigorously define the conditions of two bodies colliding to each other. The first case we are going to look at is what we call central impact. That is the easiest or the easiest form of contact. Let's, for simplicity, assume two bodies, round center of mass here. So a central impact should satisfy a bunch of conditions. First is the point of contact must be on the line of impact. So this is center, point of contact. So point of here. Point of contact on the line of impact. That is the first condition. Also, the line of impact must be perpendicular, normal to the plane of contact. So this is the plane of contact. If you have a shape that, I don't know, looks like this, two bodies like that and colliding, this is not central impact because the plane of contact is not normal to the line of impact. So this is not central. And the last condition is that the directions of motion or the velocities of two bodies are along the line of impact. So the velocities must be head on. If one of them, the velocity, is at an angle, that is no longer central impact. That is, let's call this condition A, condition B, condition C. All three of them must hold to have central impact. Another kind of contact we will look at is oblique impact. So that is the case when A and B hold, but C doesn't. So if you have these shapes, everything looks good, but if the velocities are not along the line of impact, you have oblique impact. So if they are coming head on, that's central. If they are coming to each other at an angle, that is oblique. So we start by analyzing the central impact, because it's easier. The information we gathered there can be very useful to study the second case, oblique impact. Obviously, there are many other forms of contact. So in this general cartoon I drew, to study those where the point of contact is off center, you need other tools. Some conditions easier than others, but yeah, we don't do that here. All right, so with this definition, let's go study central impact. That would be our next video.